Alicia wanted me to talk about how to find the next ore deposit. Actually, I'm not going to go that far, but I'm going to talk about the data that we have. So we keep the company exploration reports that are submitted to us under regulation in the WOMEX exploration database, which currently holds around 110,000 open file company reports with or without attached data files. All the reports are in PDF and are mostly converted to OCR, and Charlotte kindly showed you the search site that we also have, which is linked here. And they are spatially searchable via GeoView as well. Oh, and in case people don't know, the Sunset Clause, which was enacted in 1996, allows for a 5-year confidentiality period on all exploration reports, and the list of reports to be released this year in May is currently on our website. If your report is there, you do have until the end of April to send in an objection as to why you think you wouldn't like your report to be released, and we have an assessment panel that judges that. So look around, in May there will be probably around another 1,500 reports available. I'm actually going to talk about mainly about the drill holes database, which holds all the drilling that we've received with our WOMEX reports in digital format. And briefly, the final project definition for building this database was received in 2009, and a system architecture document was also developed. The first version was delivered in 2010, and the final version, which was in 2011 when we commenced actually importing historical data. The main issues we encountered were location, where we've discovered around halfway through importing the data that 30% was plotting outside Western Australia, and quite a lot of it was actually in the Northern Hemisphere. Some details of the project definition are on the screen. I won't read them out to you, but basically the idea was that it had to be incredibly flexible because we had so much variable data, and its flexibility it has a positive side and a negative side. The architecture was based on the MRT templates. Anybody who submits data to us will know what the MRT templates are, but they stand for mineral reporting templates. There have been 4 versions of the templates as they have been updated from time to time over the years since becoming mandatory in 1999. So in 1999, we required all drilling data to be submitted in a digital format. Just some statistics. There are over 4 million drill holes and associated data in the database. There are billions, I mean billions, of analytical results. We actually have 2.5 billion rows in the geochemistry attributes table. That's a lot of data. There are over 13 million total surface sample data sets as well. This map just shows the location of the holes that we have imported into the database in the last 100 days. So we're constantly importing. As the data comes into us, we're constantly importing it into the database. Of course, it doesn't. The data that we're importing currently is the data that's coming in currently. So most of that data does not become publicly available for 5 years, except for the co-funded drilling data, which becomes available very quickly. So the obvious issues are duplication of data. There's many reasons for that. People will go back and resample drill holes and submit the data again. When a report becomes available for release, so for example, when there's a partial surrender of a tenement, the data within that partial surrender area becomes available. But when the report itself becomes available after 5 years or whatever time it is, then the whole data set becomes available. So you'll then get a part of that data set will already be in the database. There's no satisfactory way at the moment to deal with that, because we can't always be sure whether it's not resampling or that it's overlapped with a partial surrender report, if that makes sense. And as I said, 30% of the original locations were outside WA. So what we've done to improve the data so far, well, originally, back in around 2020 or 19, we actually put the entire database on the Pawsey database, because we were lucky that, or maybe lucky's not so the right word, but our geophysical branch had an instance on Pawsey for doing research work, and we were allowed to use it to put the entire database there, the open file part of the database, and to allow people to go and log into it and use it if they wanted to, or to download it. And that was actually to meet a data strategy action, which was to release the entire mineral drill holes database to the cloud as soon as possible in its unclean state. This then allowed us to, just go back a step. We also wrote an analyte matching table. First of all, I have to explain what I mean, or by what we mean by an analyte, because when we released this on social media, we received a bit of criticism for the use of this term. We mean the substance that's being analysed for whatever is at the top of the column of your geochemical analysis is the analyte in our minds. And the analyte matching table, which was developed in-house by our geophysicist in his spare time, revealed 3,300 different analyte names for gold alone. And this is industry data, and 35,550 across the whole database. So, yes, sorry, 35,550 distinct entries across the whole database. We then contracted an external company to take our analyte matching table and create a searchable database, which is now hosted externally at the Western Australian Exploration Chemistry Online database, and is updated twice a year. We have also put the complete database on our Data and Software Centre in a BCP format for those people that like to use SQL databases, which is a bulk copy program. What that means is you can create the database you want. You can take just the tables that you want and create the database that you want. What we've also done is we've improved the analyte matching script. The first one was quite good, but we've got some professional database analysts to look at it and improve it. We've separated as much as handheld PXRF results where possible. We've added height data for every located point using collar location intersected with STRM. We also created an elevation table, which we added to the database. We've also created the flat tables in-house. Originally, our consultants were creating the flat tables. We've now created them ourselves, and using the maximum value of each analyte at every recorded depth. Obviously, this is not entirely satisfactory, because we're not necessarily choosing the best value according to laboratory method. We've also flagged what we consider to be suspect data, such as greater than, lower than percentage. You'd be amazed how many people have got more than 100% gold in their results. And we've also created survey tables for every colour. So what we're working on now, correcting the units of measure using lab method as a guide. We're also looking at AI to do that. Inconsistent drill depths, bringing the whole thing in-house so we don't have to host it externally and have external consultants do the work for us. We will, when we bring it in-house, we will be able to have it live updated. We're looking at AI and machine learning, as I said, and we're also looking, and this is very important, at improving the quality of the data that's submitted. And we have found that New South Wales have developed some rather clever spreadsheets which do some quite good validation. So hopefully we'll be able to, we're working on those and developing them, which will hopefully improve the quality of the data that we get. We've also created an ArcGIS Pro project, which I'll just show you. Okay, so we actually looked at niobium for some reason, minimum 1 ppm, zoomed into an area, plotted the drill holes, and then created a 3D scene. It's just to show you what you can do with ARC. It's pretty clever. And then what about the other data sets in WAMEX? There's a huge number of actual digital data sets attached to the reports in WAMEX. The two that we're currently working on are the ground gravity data sets. We've actually extracted a set from the Mount Bruce sheet and produced some harmonised data and some images. Those are available on the Data and Software Centre. And the 3D models, there's quite a lot of 3D modelling attached to the database, and that is going to be used, that is being programmatically extracted and is going to be used as a source of open source data at the upcoming 3D Geological Modelling Conference, which is being held in Fremantle. I just wanted to acknowledge the three people that have been instrumental in doing this. David Howard, our chief geophysicist, who wrote the first analyte matching table and who loves to write code on his weekends, and he's now writing us an application to extract gravity data and process it. Michelle, who supported us, particularly David and myself, when we started doing this in 2020, and now the vast majority of the work is carried out by one of our internal consultants, John Cuthbertson, who's just absolutely an amazing database analyst and manager. Thank you very much.